1 to the power of infinity form. This is also one indeterminate form. So for this, how to do? For this and for this we are using L'Hospital rule. For this, what to do? Here limit is like this, fx to the power of gx as x tends to a. This is a 1 to the power of infinity form. That means limit of fx as x tends to a is 1 and limit of g of x as x tends to a is infinity. Then what to do for this? You have to apply e power limit of fx minus 1 into g of x as x tends to a. Directly if you use this, then we will get the limit for this. For example, limit of as x tends to 0 1 plus x square to the power of g of x should tend to infinity, cosecant x, let us say. This is f of x, as x tends to 0, this is tending to 1, and as x tends to 0, this is tending to infinity. So 1 to the power of infinity. So I will apply this one, e power limit as x tends to 0, fx minus 1, that is 1 plus x square minus 1 into g of x, that is cosecant x. So that is e power limit as x tends to 0, here x square by sin x, that is e power limit as x tends to 0, x into x by sin x. As we know, this is tending to 1 and this is tending to 0. Both are finite, so that is tending to 0. Or again, I can say x square, this is tending to 0, this is tending to 0, 0 by 0 form. So I can apply L'Hospital rule, differentiation of this is 2x, differentiation of sin x is cos x, as x tends to 0, this is 1. Therefore 0 by 1, 0 only, that is e power 0, that is 1. Finally, limit of this is 1. So when the limit is in the form of 1 to the power of infinity, directly this is the method of finding the limit. Okay. This is one indeterminate form. One more. Limit of x tends to infinity, x square plus 2x minus 5 by x square minus 3x plus 4 whole power x. As x tends to infinity, this is tending to 1 and this is tending to infinity, 1 to the power of infinity. Because we know limit of x square plus 2x minus 5 by x square minus 3x plus 4 as x tends to infinity. When x is tending to infinity, we have to divide with the highest power of x. So this comes out to be limit of 1 plus 2 by x minus 5 by x square by 1 plus 1 minus 3 by x plus 4 by x square as x tends to infinity. When x tends to infinity, 1 by x tends to 0. So this is 0, this is 0, this is 0, this is 0. This comes out to be 1. So this limit is 1. 1 to the power of infinity form. Limit of x square plus 2x minus 5 by x square minus 3x plus 4 minus 1 into g of x. So this comes out to be limit as e power x tends, limit as x tends to infinity, x square plus 2x minus 5 minus x square plus 3x minus 4 by x square minus 3x plus 4 into x. X square cancel. This comes out to be limit as x tends to infinity, 2x plus 3x, 5x, 5x square and minus 9x by x square minus 3x plus 4. As we have done already for this dividing by x square, this becomes 5 minus 9 by x, and this is 1 minus 3 by x plus 4 by x square as x tends to infinity, except 5 and 1, the remaining all become 0. So, e power 5 is our limit. Limit of this is a e power 5. So, this is 1 to the power of infinity form. This is one more indeterminate form. Now, one more indeterminate form is infinity to the power of 0. This is limit of fx to the power of gx as x tends to a is infinity to the power of 0 form. That means limit of fx as x tends to a is infinity, and limit of fx as x tends to a, limit of gx as x tends to a is 0. Then for this I will use e power limit of limit as x tends to a ln of fx into g of x, ln of fx into g of x. As we know, as fx tends to infinity, ln of fx is tending to infinity. This ln of fx is tending to infinity. G of x is tending to infinity. This is in the form of 0 into infinity. So, for that e power limit as x tends to a, I will write like this, limit of ln of fx by 1 by g of x. As fx is tending to infinity, ln of fx also is tending to infinity. So, this is infinity.